All right, we're going to start back up with number 11. Number 11 says if a car accelerates accelerates at 3.5 meters per second squared for, what will its final velocity be after 4 seconds if it starts off with an initial speed of 7 meters per second? So there we go. That's our information. So we're looking for the final velocity. All right, looking for this final velocity. So the only formula of final velocity is A is equal to VF minus VI over T. So we've got 3.5 equals VF minus 7 over 4. 4 times 3.5 is 14 equals VF minus 7, add 7 to the other side, and we get 21 equals VF. And that's 21 meters per second equals VF. All right, so that's number 11. Number 12 says if a hoverboard can start with an initial velocity of 20 meters per second and achieve a final velocity of 80 meters per second, accelerating at 10 meters per second squared, how long would this take? So initial velocity is 20 meters per second. Final velocity is 80 meters per second. Acceleration is 10 meters per second squared. Time is equal to question mark. So what we're going to do is we're going to do A equals VF minus VI over T because we have the final velocity. And we're going to do 10 equals 20 minus 60 over, or sorry, not 60, 20 minus 80 over T. That's not right either. Sorry. It's 80 minus 20. 80 minus 20 over T. And so we get 10T equals 60, and T would be equal to 6 seconds. So it would take 6 seconds for that to happen. All right, number 13. All right, a small child is thrown up into the air by the father, and we want to know the initial velocity, and we also want to know how long the child was in the air. So we want to know initial velocity and the total time. And we're given the height the child was thrown to, which is 0.7 meters. Okay, so if the child went up 0.7 meters, he had to come down 0.7 meters. And we know the velocity up here at the top is 0. And so that's important because what that's going to allow me to do is to divide my problem in half, and I can say the initial velocity on the way down equals 0. Okay, so initial velocity on the way down is 0. That means that I can use d equals 1/2 at squared plus vit to solve for the initial, or solve for the time, because I can plug in 0.7 now, and I know a is negative 10 because it's in free fall, and I know t squared is my unknown. But since I can divide that problem in half and just look at this side, I can call initial velocity at the top 0, initial velocity on the way down is 0, and so that allows me to ignore that term and solve for t. So I get 0.7 equals negative 5 t squared. Remember the 7 needs to be negative because it's falling that far, and so we divide by negative 5, and we get t is equal to, we get 0.14 when that happens, and then that's equal to t squared, square root, and we get 0.37 seconds equals t. Now that's the time down, right? So the total time then would be 0.74 seconds, okay? Because that would be the time it would take to go up and come back down. All right. Remember that time up is equal to time down. So what we're going to do next is we have the time it takes to go up. Time up would be 0.34, or rather 0.37 seconds. Acceleration is equal to negative 10. And now what we're going to do is we're going to look at this other side of the problem, and we're going to say that initial velocity is unknown, but the final velocity at the top is equal to 0. And so what that's going to do is allow us to do A equals VF minus VI over T. And so we get negative 10 equals 0 minus VI over 0.37, and we get negative 3.7 equals negative VI, or 3.7 meters per second equals VI. There we go. And again, this was number 13. Okay, number 13. All right. Let's see. Number 14. Number 14 is a bullet is fired straight upward with an initial velocity of 250 meters per second. And that's all it gives us. It wants to know how long was it in the air, so the total time. It wants to know the height. How tall is it? How high did it go? It wants to know VF at the bottom. Well, we can go ahead and answer the VF at the bottom. That's negative 250 meters per second, because if it shot up at 250 meters per second, it has to hit at 250 meters per second. Okay? And it's negative because it's going down. Okay, so if we wanted to do this, we need to find a time. So I have VF and I have VI. VI is equal to 250. VF is equal to negative 250. So we're going to use we're going to use A equals VF minus VI over T to solve for the total time. That'll give us the total time. So we get negative 10 equals negative 250 minus 250, and it gives us and that's times time, 10t, and then we divide, and we get t is equal to, skipped a step there, sorry, divided by t, so we get negative 10t equals negative 500, and t then equals 50 seconds. Now, mind you, that's the time it takes to get up and down, so that's 50 seconds up and down. So the time it takes to get to the top would be 25 seconds. Why do I need this? Because this is the time we use to calculate the height, because it's the time it took to get halfway there. 1/2 AT squared plus VIT. So we plug it in and we get D is equal to 1/2 times 10, negative 10 times 25 squared plus 250 times 25. And when we solve, we get D is equal to 3,125 meters. Alright, so there we go. We've got all of these now. 3,125 meters. Next up, 15. This is the one about the seagull. So the seagull drops a clamshell in order to crack it, and what it gives us is the time. So time is equal to 2.3 seconds. Initial velocity is equal to 0. Acceleration is equal to negative 10 meters per second squared. So we get, if we're trying to figure out how fast the clam was going, that's VF. So to find VF, we use A is equal to VF minus VI over T. The reason we use this one, again, is because it's the only one with the final velocity. So we get negative 10 equals VF minus 0 divided by 2.3, and negative 23 meters per second equals VF. It's cool that it's negative because that means it's going down. Alright, and then for distance, I need to use the D equals 1/2 AT squared plus VIT. Initial velocity is 0 because they dropped it, and D is equal to 1/2 times negative 10 times 2.3 squared. And if we do this, we get the answer of negative 26.45 meters. Okay? So there you go. Those are the main ones. 16, if you have a positive velocity and a negative acceleration, it means your object is slowing down. And that's number 16. Number 17, which would hit the ground first in a vacuum, it would be the same. They would hit the same time, because air resistance is what keeps things from falling 10 meters per second squared. So if there's no air resistance, they would hit at the same time. And then number 18, last one. Number 18 is a photogate. That's what those things were called, a photogate. Alright? If you have any questions, feel free to tweet me or email me.